Hi guys, I'm Rayhan and today we're gonna talk about a lesson called discovering parts of an atom. It's a very important lesson, and some of the concepts or things we're gonna learn in today's lesson are um, what is an atom and how would you describe the size of an atom, and how has the atomic model changed over time. The keywords for today is atom, electron, nucleus, proton, neutron, and electron clouds. You will learn about them now. Earlier is about matter. Democritus believed, a scientist or philosopher called Democritus, believed that all that matter is made of small solid objects that cannot be divided, destroyed, or created. Okay, his time was from 460 to 370 before Christ. Okay, and he proposed that different types of matter are made of different types of atoms, small subjects. But yeah, matter is made of small solid objects called atomos. He called atomos, from which the English word atom is derived. Democritus proposed that different types of matter is made of different types of atoms. For example, uh, he said that smooth matter is made of smooth atoms. Yeah, atoms. He also proposed that there's nothing between these atoms except empty space. Okay, this table here summarizes his ideas. One, or his atomic theory. Number one, atoms are small solid objects that cannot be divided, created, or destroyed. Number two, atoms uh, atoms are constantly I was looking to something else, so I could just see if it's exactly okay. Let's complete. Two, atoms are constantly moving in empty space. Three, different types of matter are made of different types of atoms. And four, the properties of the atoms determine the properties of matter. Yeah, the properties of atoms determine the properties of matter. Because why? Because the atom is the smallest thing that can still represent the element that it is from. Like an atom of carbon, it is the smallest thing that it can still represent carbon. Let's go to the next one, who is Aristotle. Aristotle, from 384 to 322 before Christ, did not believe that empty space exists. Did not believe that empty space exists. Instead, believed that all matter below. Instead, he favored a more popular idea, or believed that all matter is made of fire, water, air, and earth. Because Aristotle was so influential, his ideas were accepted, and Democritus' ideas about atoms were not studied again for more than 2000 years. He was very influential that people accepted his ideas. He was like the people believed him. But this idea now they said that it's wrong. Okay, Dalton's atomic model. Okay, John Dalton. Okay, he's also a scientist. He's John Dalton, in the late 1700s, English school teacher and scientist. John Dalton, his 1766 to 1844, revisited the idea of atoms. Since Democritus' time, advancements had been in technology and scientific methods. Dalton made careful observation and measurement of chemical reactions. Yeah, John Dalton combined data from his own scientific research with data from other scientific research to propose a new atomic theory. New atomic theory. His atomic theory was John Dalton's atomic theory. All matter is made of atoms that cannot be divided, created, or destroyed, just like Democritus. And number two, during a chemical reaction, atoms of one element cannot be converted into atoms of another element. Like he said that during an chemical reaction, like atoms of one element, like atoms of carbon, cannot be converted into another element. Atoms of another element, like from carbon to oxygen during a chemical reaction. That's what he said. That's what he said. And number four, atoms combine in specific ratios. Ratios. Yeah. Um, yeah, he said that. I think now they think it's wrong or something. I don't know, but oh yeah, it's. I think it's different from now, but he's old. But this is what his atomic theory. Yeah, the atom. An atom is the smallest piece of an element that still represents the element. That's what I told you before a little bit. Okay, the atom. Atoms of different elements are different sizes, but all are very, very small. Yeah. You cannot see atoms with just your eyes or even with most microscopes. Like atoms, you see this the period at the end of the sentence. About 7.5 trillion atoms could fit in it. 7.5 trillion carbon atoms could fit in it. Okay. The 1981 invention of a high-powered microscope called a scanning tunnel microscope, or shortcut STM, enabled scientists to see individual atoms for the first time. That was the first time for scientists to see the atoms. Scientists have learned that atoms are not the smallest particles of matter. The others, yeah, don't be confused. Don't let them confuse you. The smallest particle that can still represent the element is atom, but the smallest particle of matter is not the atom. There's a smaller than the atom. Yep, there's a difference, and we'll learn about it in the rest of the lesson. We'll say what is it. Now let's go to Thompson. J.J. Thompson. Not long after Dalton's findings, another English scientist named J.J. Thompson, J.J. Thompson, 1856 to 1940, made some important discoveries. Following his experiments with cathode ray tubes, scientist J.J. Thompson concluded that cathode rays were made of small negatively charged particles, which he called electrons. Yeah. He made a research. He bought a cathode ray tube, which is a glass tube that has been evacuated or vacuated. That he removed most of the air from it, and then he put a battery and a piece of metal called electrode. The electrode were connected to wires, and the wires were connected to a battery. Thomson discovered that if most of the air was removed from the tube and electricity passed through the wires, greenish-colored rays traveled from one electrode to the other end of the tube. What were these rays? What is this rays? Yeah, what are these rays? Now we're going to see. An electron is a particle with a one negative charge. Yeah, these rays are scientists called these rays cathode ray tubes. Thomson wanted to know if these rays had an electric charge. To find out, he placed two plates on the opposite side, as you see here. Electrical charge plate. Yeah, as you see here. This is a plate, and this is a positive plate, and this is a negative plate. Wanted to see on the opposite sides of the tube. One plate was positively charged, and the other plate was negatively charged. Thomson discovered that these rays are bent toward the positively charged plate, as you see in the picture, and went and repelled from the negatively charged plate. Why? Because things that have opposite charges attract each other, and things that have same charges repel each other. And that's why he concluded that these rays are uh, have a negative charge, and they are made of something called electrons, which are part of an atom. These electrons have a negative charge, have a one negative charge. As we read here, an electron is a particle with a one negative charge. Yeah, as we said. Okay, now let's go. Because atoms are neutral or not electrically charged, atoms are neutral or not electrically charged. Thompson proposed that atoms also must contain a positive charge that balances the negatively charged electrons. If the atoms were neutral, uh, there must be a positively charge, a positive charge in the atom that balances the negatively charged electrons. Thomson proposed then that atom was a sphere. He said that atom was a sphere with a positive charge throughout, evenly spread throughout, and negatively charged electron within it. He said that like a chocolate chip cookie was mixed in a chocolate chips were mixed in a cookie dough. It's shaped like a cookie. Let you see. Just a second. Let yeah, Thomson's atomic model. Thomson's atomic model. Yeah, here's it. Let me tell you the images. See, like this. It's like this. See, that's what he said. And it's now not believed that it's right. Now the modern, we're gonna take it about. Yeah, this is a picture of it. Also, Thomson model of an atom contained a sphere of positive charge with negatively charged electron. Now let's go to the scientist who's called Rutherford. The discovery of electrons scientist Ernst Rutherford, 1871 to 1937, was a student of J.J. Thomson, who eventually had students of his own. Rutherford's students set up experiments to test Thomson's atomic model and to learn more about what atoms contain. They discovered another surprise. They discovered a very big surprise that surprised them. Yeah, Rutherford's predicted result was like now I'm read it for you. Scientist Ernest Rutherford set up experiment to test Thomson's atomic model and learn more about what atoms contain. Yeah, this is what Rutherford and his students um, expected to happen when they shot alpha particles at a thin gold foil. That's what they expected to happen. This is a screen, and they expected that the alpha particles, which are very dense particles, that they need another dense particle to change their path. Uh, change their path. Is a very dense particle that they expected so it could move through the gold foil as if nothing is happening. That's what they expected. They expected that the alpha particles will knock away they will move in a straight path. Rutherford expected the positive alpha particle to travel straight through the foil without changing direction. That was they expected. Imagine throwing a baseball into a pile of table tennis balls. The baseball likely would knock the table tennis balls out of the way and continue moving in a relatively straight line. That's what they expected in the same here, but here alpha particles and gold foil, very thin gold foil. But here what happened? Here what happened? Some alpha particles travel in a straight path as expected, but some changed the direction and some bounced straight back. That was the surprising result. Most of the particles did indeed travel. Did indeed, did indeed, yeah, well, yeah. Most of the particles did indeed travel through the foil in a straight path. However, a few particles struck to the foil and bounced off to the side. Some of the particles went bounced straight back. Rutherford later described this surprising result, saying it was almost as incredible as if you had fired a 38 centimeter shell at a piece of tissue paper and it came back and hit you. The alpha particles must have struck something dense and positively charged inside the nucleus or inside um, the atom. The nucleus is not the atom, but they I think they thought before that it is an only a nucleus or something like this. Thompson's model had to be refined. Let's complete in Rutherford's uh, atomic model. Yeah, Rutherford concluded that most of an atom's mass and positive charge is concentrated in a small area in the center of the atom called the nucleus. Called the nucleus. Additional research showed that positive charge in the nucleus was made of positively charged particles called protons. These small particles that we talked about before, that we said that they make the atom, one of them is the protons. Let me show you Rutherford's atomic model. Rutherford atomic model. This was one of his atomic models. These are his atomic models. That's how he said. Okay. Yeah. Rutherford. Yeah. We said this. A proton is an atomic particle that has one positive charge. It's a positively charged particle. Negatively charged electrons move in the empty space surrounding the nucleus. Negatively charged electrons move in an empty space surrounding the nucleus. Now, some of you will ask me how the nucleus is made of protons, and protons are made of all positively charged, and they are close together. How they don't repel each other and go away. Now, I'm gonna tell you about it. The Rutherford model contains a small, dense positive nucleus. Tiny negatively charged electrons travel in empty space around the nucleus, discovering neutrons. James Chadwick. Yeah, where? Yeah. So the modern model of the atom was Rutherford's colleague James Chadwick, 1891 to 1974, also researched atoms and discovered that in addition to protons, the nucleus also contained neutrons. That's what I'm about to tell you. Neutron are like they put it in the nucleus for many things. One of these things is to uh, catch the uh, protons and don't let them go away and spread out, uh, because they are neutral. They are neutral. A neutron is a neutral particle that exists in the nucleus of an atom. That exists in the nucleus of an atom. Yep. Uh, that exists in the nucleus of an atom. James Chadwick discovered that in addition to protons, the nucleus also contains neutrons. A neutron is a neutral particle that exists in the nucleus of an atom. Bohr's atomic model. Niels Bohr. Rutherford's model explained. Okay. Rutherford's model explained much of his students' experimental evidence. However, there were several observations that the model could not explain. For example, scientists noticed that if certain elements were heated in a flame, they gave off specific colors of light. Each color of light had a specific amount of energy. Where did this light come from? Niels Bohr, 1885 to 1962, another student of Rutherford's, proposed an answer. Bohr studied hydrogen atoms because they contain only one electron. He experimented with adding electric energy to hydrogen and studying the energy that was released. His experiments led to a revised atomic model. Niels Bohr proposed that electrons move in circular orbits or energy levels around the nucleus. Oh yeah, that's we were about to say. Yeah, PP. The things that I said before later was not that important, but the only thing important in it, the key day of Niels Bohr, which is 1885 to 1966. 1962, I mean, sorry, 1885 to 1962. Electrons in the Bohr model. Bohr's model is shown. Yeah, Bohr proposed that electrons move in circular orbits or energy levels around the nucleus. Electrons in an energy level have a specific amount of energy. Electrons closer to the nucleus have less energy than electrons farther away from the nucleus. When energy is added to an atom, electrons gain energy and move from a lower energy level to a higher energy level. Niels Bohr proposed that electrons move in circle. And electrons closer to the nucleus have less energy than the electrons farther away from the nucleus. He said that electrons that are closer to the nucleus have less energy than electrons farther away from the nucleus. When the electrons return to a lower energy level, they release a specific amount of energy as light. This is the light that is seen when elements are heated. Let me show you the Bohr's atomic model. Yeah. No, wait a second. Quickly go. Hey. Yeah. Bohr's atomic model. Let me show you images for it. This is his atomic model. This one, you're gonna see about it now. Let's continue. Bohr's atomic model. More research showed that although electrons have specific amount of energy levels are not arranged in circular orbits. They are not arranged in circular orbits. That's what more researches showed. When an electron moves from a higher energy level to a lower energy level, energy is released sometimes as visible light. Here's the Bohr's atomic model. In Bohr's model of the atom, electrons move in circular orbits around the atom. The modern atomic model, yep. The modern atomic model was the model of the atomic model of today. In the modern atomic model, electrons form an electron cloud. An electron cloud is an area around an atomic nucleus where an electron is most likely to be. An electron cloud is a place or an empty space or an area around the nucleus, that it is the most likely place electrons could be in it. Scientists now said that it is impossible to know both the speed and exact location of an element at a given moment in time. Now they say it's impossible for them to know the exact speed and look to know the speed and exact location of an electron at a given moment in time. Instead, scientists only can predict the likelihood that an electron is in a particular location. The, what they mean that now they only can predict where the electron is most likely to be. The electron where it is most likely to be, they predict where it is. In this atom, electrons are more likely to be found closer to the nucleus than farther away. See this place, this circle? It is the most likely place, not this dot. No, the dark circle is the most likely place to be the electron in it. Okay. Quarks. Protons and neutrons are made of smaller particles called quarks. Electrons are not made of small particles, but protons and neutrons are made of smaller particles called quarks. Scientists theorize that there are six types of quarks: up, down, charm, strange, top, and bottom. Protons are made of two up quarks and one down quark, and neutrons are made of two down quarks and one up quark. The current atomic model might change with the invention of a new technology that aids the discovery of new information. Now, let's read this. If you were to divide an element into smaller and smaller pieces, the smallest piece would be an atom. Atoms are so small that they can be seen only by using a very powerful microscope. Scientists know that atoms contain a dense positive nucleus surrounded by an electron cloud. Now let's go to questions. Which term describes a particle with one negative charge? Which term describes a particle with one negative charge? Tell me in the comments before I go down. What is it? Yep. Who said electrons? It's right. Electron. Before I say yeah. Whose model of the atom contained a sphere of positive charge with negatively charged electrons within it? Who? Which scientist? Tell me in the comments before I go down to the answer. Yep. Who said J.J. Thompson? It's right. Now, after question, oh shit. Oh, okay. Which term refers to an area around the atomic nucleus where an electron is most likely to be? What is this? Which term refers to an area around an atomic nucleus where an electron is most likely to be? We just said it. Who said electron cloud? It's right. What do you think? Do you agree or don't agree? The earliest model of an atom contained only protons and electrons. Protons and electrons. Do you agree? Who agrees? Put for me down there. Air fills most of an atom. Who agrees? Put it down in the comments. And in the present day model, or the modern model of the atom, the nucleus of the atom is at the center of an electron cloud. Who agrees with this? Who agrees? Tells me, please tell me down in the comments. And thank you for watching. This was the video for this week, and see you next week. Goodbye.